In this assignment, we're going to look at a harder problem in Solver. So this problem is about hot tub production. A company manufactures 5 different models of hot tubs in 2 plants, both of which are located very near the sales outlet, allowing for transportation costs to be ignored. Table 1 presents the sales price per unit, the production cost per unit per plant, and the annual minimum and maximum production levels. The minimum and maximum production amounts are the total production numbers for both plants combined. The company can sell every unit it can produce. Develop a model to determine the optimal number of units of each of the 5 hot tub models to be produced at each plant, aiming to maximize profit. Hints: add a constraint to limit the solution to integers. The objective will be to maximize total revenue minus plant 1 production cost minus plant 2 production cost. And then we'll seed the decision variables with 2's, and after successfully running Solver, we'll create the named ranges. All right, as a reminder, as far as conventions go, we do have heading conventions. The red cells are the decision variables. This is what Solver is all about, right? Determining what these numbers are going to be. And it's going to determine what these numbers are going to be subject to the constraints. And so you're going to have constraints here about a minimum and maximum production levels, right? So between 20 and 25 of the Grand Canyons, between 30 and 125 of the Super Soakers, between 78 and 300 of the Hydro Lux, between 76 and 375 of the Aqua Spas, and between 120 and 500 of the Hydrolators. So that's one set of constraints. That's in terms of total produced between the 2 plants, plant 1 and plant 2. Now we also have separate constraints for each plant. So plant 1 down here only has on hand 850 pumps, 1,800 fiberglass, and 2,000 in the tubing. Plant 2 has available 300, 1,200, and 900. So we've got to make sure that we don't try to produce more of using parts in plant 1 than we have parts available. And similarly, we got to try to make sure that we don't produce more in plant 2 than we have parts available. So that's going to factor in also to these final numbers. And then finally, the last thing to factor in is we do have the revenue per unit. In other words, how much we make selling a Grand Canyon, how much it costs us to produce that Grand Canyon in plant 1, how much it costs us to produce it in plant 2. And you notice that those are a little bit different, right? There's different efficiencies in different plants for the different products. And so then we take all of that, compute our total revenue, subtract the production cost of plant 1, subtract the production cost of plant 2, right? And that would be our net profit, which we want to maximize. We're running some conventions here. So the red cells are decision variables, yellow are the constraints, which we just mentioned. The gray or orange cells, like these here, are intermediate calculations. You see some here, 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 and here. And then finally, the green cell is the ultimate objective behind Solver. We're also going to use as a legend here that if you see any cell that has this double light blue line around it, those cells will remain pink until the final solution. So if you see those go pink, it doesn't mean that you've done anything wrong. Unless you run Solver and they're still pink, then that's a problem. And I did that instead of putting next to each one, pink until solved, etc. So we're just going to use that as the convention. So let's go ahead and get started. So first of all, we concede all of the decision variables of 2s, and that way as we do the calculations we'll actually see some numbers there. And you'll notice these are pink because those obviously aren't going to be the final numbers. By the way, I've also shown these as decimals, even though they're going to be integers. The reason I did that is to make sure that we don't forget to put the constraint that they do have to be integers. So if you actually end up with a number that's a decimal, then you know you've forgotten to add that constraint. All right. So let's go ahead now and get our total produced. So if plant 1 creates this many and plant 2 creates this many of the Grand Canyons, then the total produced between the two plants will be to add those two together. So that's going to be sum of those two together. And we'll copy that across. And again, these are the double blue outline cells. So they're pink until solved. The sign is going to look like that all the way across. I can grab the little arrow. There we go. And same here. And then over here, this is kind of interesting. What do we do with this? All right, so now we're looking at just plant 1 and the parts used. So this is the number of parts that you need per item produced. This is how many you're going to produce in plant 1. So if we multiply all of those together and add them up, we should get the right total. So we'll use the sum product for that, which does the multiplication and the adding in one step. It's a really nice function. And so this is only for plant 1. So sum product, there's plant 1. We're going to lock that because this formula is going to be copied down. And then we're going to multiply those numbers times these. And then copy that formula down. And then those numbers do have to be less than the amount available. And we're going to do the same thing over here for plant 2 equals sum product. This time we're going to pick up the plant 2 line, which are these. Lock that. And we're going to multiply it by, oops, sorry, by this, which is not locked. And then copy that down as well. And then all of those need to be less than here. And now we've got to get our total revenue. All right, so how are we going to get total revenue? Well, so we'll get total revenue by looking at total produced between the two plants, which is going to be this set of numbers here, times what? Times the amount that we charge for each of those products from each of the plants. So that's going to be sum product and I don't have to lock this because I'm not copying this formula. Well, actually, yeah, I'm not copying the formula. And then our production cost for plant 1, so now we're just plant 1, is going to be what we produce in plant 1 times the production cost per unit in that plant. And similarly for plant 2. This time, just plant 2 times the production cost per unit in plant 2. All right, and then our profit is going to be equal to revenue minus plant 1 production cost minus plant 2 production cost, and that'll be our final profit. But this isn't maximized. Those aren't supposed to end up being 2s. We want all of these pink cells to go green. So this is what we need solver for, right? This would be very hard to do and balance all of this simultaneously unless we had solver. So we go to the data tab, kick off solver, set our objective. This time it's actually max. And we're going to do this by changing variable cells. Let me drag this out of the way so I can work with it as I add the constraints. So these are the decision cells, the decision variable cells. Then we're going to add a bunch of constraints. So first constraint is that these items, right now looking this way, from here to here, it's going to be greater than the minimum, right? So the sign's going to effectively flip because we're looking at it from the perspective this way. Greater than or equal to the minimums. Add another constraint that those same values these are going to be less than or equal to, because looking this direction, less than or equal to the maximums. Add another constraint that we want these numbers here to be less than or equal to these ones. And add another constraint that we want these numbers here to be less than or equal to these numbers. Let's see where we are so far. Okay, so those are the 4 constraints that we have so far. And then we do have one more, because the problem actually says that the final answer in here, these all have to be integers. So let's add that constraint. So we add a constraint that all of these 8 have to be integers, and so we say int for integer. And there it is. So now let's pick the options. And if you've forgotten these options, you can always pick them up from the yellow tab down here, which will show you what these options should be. So that's simplex, and then it's check, uncheck, uncheck, integer optimality, 0, and maximum time is 10. And then we'll solve. If you get this sometimes happens on a Mac, and the no cells were found, just keep clicking OK, OK, OK. And somehow it comes back to life. Solver found a solution. You notice everything went green. And so we'll go ahead and click OK. If it didn't, obviously go back and fix something. And what this is saying is that if we set these numbers where they are here, our profit will be $1,881,300. All right. Now, we know we got it right because scoreboard's showing it right, but we really do need to document this. And we document by labeling the different ranges. So let's start. we'll go to the Formulas tab. We're going to use the Create from Selection again. So we're going to highlight these, Create from Selection, and these are Plant 1 units produced. Highlight these, Create from Selection, Plant 2 units produced. And then we'll go ahead and highlight these, highlight these, highlight these, all right, then highlight this way, this way, this way, here, and then finally here. Well, maybe not finally. All right, so it looks like we've got most of the ranges highlighted. Let's go back to Solver and see what we're still missing. So I'll come back to the Data tab. And you can see that almost everything is labeled, except actually this one and this one. And the reason for that is because we did these Plant 1 and Plant 2, but we didn't do the two plants together. So let's do that. Now in this case, I won't have a label that I can pick up of the two together. So this one I'm actually going to have to sort of manually name. So I'm going to highlight these, and then I'm going to have to give them a collective name. So if this is Plant 1 and Plant 2 units produced, I'll call it all units produced, no spaces. And then after I type that up here in this little box, I'll show you. After I type it here, I do have to for it to actually take the name, have to enter the return or enter key. And then now if I highlight this, it should show the name. So it looks like it did name those. Now if I go back to Solver, it's got that. So our objective is total profit max, and that's going to be maximized by changing the variable cells all units produced, which are these 8. All units produced must be integers. Plant 1 used has to be less than Plant 1 available. Plant 2 used less than Plant 2 available. The total produced needs to be less than the maximum total produced, and the total produced needs to be greater than the total produced minimum. Okay, so we've got those constraints. And it's funny, the constraints kind of come out of order because the most recent one comes to the top. So there's the integer constraint, there's these constraints, the next two, and then finally these constraints here. All right, so we're going to want to take a screenshot of this. And then use that down here as our documentation. And then we're also going to want to paste in those named ranges that we created. So we'll go back to formulas, using formula, paste names, paste list. And we're good to go.